Okay guys, this is MATH6610 Quantitative Methods. This is the first video. As we would do in any class, one of the first things I want to do is go over the syllabus with you. So let me bring that up. This is a 2-hour course, and our on-campus sessions are yet to be determined. I'm pretty much leaving that up to Dr. Whitaker to decide when he wants to meet with you for analysis 2. I'm not going to need, it seems like he's going to need 5 on-campus sessions. I don't need that many. For the most part, I'm going to need 2, maybe 3. And for obvious reasons, we want to work together where we can have the on-campus sessions for analysis 2 and this class on the same dates and times. Well, not the same times, because it'd be kind of weird to take an analysis 2 in this class at the same time. But I think you know what I mean. Catalog description, guys. In a nutshell, what happens here is we start with very simple illustrations of statistical techniques that may be used in education research. We start simple. We get into some pretty complicated designs later on in the semester. We ultimately look at some factor analysis, principal component analysis, and we even get into some non-parametric designs. Down here at the end it says, time permitting, multiple logistic regressions techniques may be presented. They will not. We've taken this class from a 3-hour course to a 2-hour course, so there's no way that we're going to get that far. So I'll tell you what, let's just get rid of that, because that doesn't apply. There's the goals. A couple of textbooks. I make these optional because they're just expensive. And I don't want you running out spending your hard-earned money on textbooks when I'm going to pretty much via these videos tell you everything that you need to know. Now, one update on the software, you guys should be set to go with R. You should have that downloaded. But you're also going to need something called G-Power. And I'm going to illustrate how to download that in just a second. So, disability statement, take a look at that. If any of you have anything going on there, let me know. Class policies are simple. Expect you to watch all the videos. I don't expect you to just sift through the videos and try to find the parts that apply to the homework assignments. Caught some of my students doing that this summer in the 6600. And it's really easy to tell, because there's going to be times that I'm going to tell you to download certain packages on R. And if you don't watch the entire videos, you're going to miss that. And then when it comes time to run the analysis, you're going to say, hey, Dr. Darber, I can't get this to work. Well, you didn't watch the whole video. You're just skipping around. Guys, you need to watch it entirely. Just as you would expect your students to come and sit in your lectures the entire time. The obvious is with you guys. So I expect you to watch the entire videos and lectures. Guys, you're going to have approximately 5 assignments. You'll have a midterm, and you'll have a final project. So here's what will happen. Working on the assumption that we meet twice. The first time we meet, you'll take your midterm, and at that time, we'll start talking about a final project. Your final project will be presented in writing, and you'll get up and do a 10-minute presentation to the class on your research statement and the analysis that you conducted and what you actually found. I'm not going to go over that today in a lot of detail, other than just to let you know that is going to happen. So really, only one exam. That'll be the midterm, and of course your final project and the 5 assignments. The grading criteria, as you can see here, 40% of your final grade are on assignments, and 60% of your final grade will be on your exam and your presentation. The grading scale is a little different than it was in regression. Regression is a much tougher class, so it was a little easier. I don't know about easier, but the range for an A was wider. Let's put it that way. So this will be the grading scale for A's, B's, and C's. All right. So guys, having said that, let me explain a little bit about our program and a little bit of the history, and to give you a better indication of what's going on with this particular class. About 2 years ago, I was actually chair of the math department at the time, and the associate provost at that time asked if he could come up and talk to me. And what he had on his agenda was us starting a Master's in Mathematics program here at Shawnee State. Well, the first thing we did when we met as a group to decide whether or not we wanted to offer this is we had a big old question mark. What was our program going to look like? And considering that the the goal was closely tied into the dual credit phenomena, the attention that the state of Ohio is bringing to dual credit and credentialing teachers to teach dual credit, credentialing teachers to actually teach all college level courses, and dual credit falls under that heading. We felt that our program should have two components. First thing it should have is we should have a strong math component. The next thing that we had on the agenda, and we all agreed on, is this thing should have some sort of an education component. Now I'm going to put that in quotes because we had no idea what that was going to look like. In fact, we had no idea initially what the math part was going to look like. Well, as we met, and Dr. Whitaker and Dr. Nichols and Dr. Maxon and all of us sat down and met, it turned out that this part over here was really, really easy. We had decided that we wanted 27 credit hours in our math component. We knew we wanted 36 credit hours total. So the education, if we can just do some simple subtraction, had to be 9 credit hours. Well, what were these 27 credit hours going to look like in the math? Well, again, that turned out to be really, really easy because as we sat down at a table together, we started looking at what were the first 2 years of our math background at the graduate level. What did that look like? Well, I'm from the University of Kentucky. Dr. Whitaker's from LSU. Dr. Maxon from Nebraska, and so on and so forth. And you know what? We found out that there was a lot of commonality. We took analysis. We used the same textbook. We took algebra. Most of us used the same textbook. We had some applied, some statistics. We had some probability. We had some, foundations of geometry. We had some linear programming and complex variables. At the end of the day, there was so much commonality that the math part turned out to be the easy part. Well, then our discussion changed to what's the education part going to look like? Well, that's where things got tricky. The first thing that we taught or thought about with education was, well, let's create some courses that emphasize or improve the teaching of mathematics. Well, who's going to offer that? We didn't have anyone in the math department capable of doing that. The education department, we didn't really want to bring them on board for reasons I'm not going to go into. So the teaching part really turned out to be to not make much sense. So we're sitting there thinking, just what the heck is this thing going to look like? And we met and we met and we met numerous times, and we couldn't come up with it. So finally, Dr. Maxon, I remember the hallway one day, she said, Doug, we got to come up with something. I'm turning it over to you. Come up with what you think this education component should look like. So after many, many sleepless nights, I finally thought, what education component can connect high schools with college? What can connect these two? And it was pretty I can't talk and write, so please forgive me. It seemed to me that the answer was research. Wouldn't it be cool if the people in the high school who were teaching our dual credit courses also knew how to conduct valid research to where we could communicate, and use this to improve instructions. Improve instruction and improve our programs. So, went to the committee. I said, guys, let's think about research. Well, what do we need? Well, the first thing we needed under the research is a project. And guys, each of you will end up doing, and then actually the projects will be in group form, your capstone to the master's, if you stick with us through the entire program, will be to submit a project. Well, a project requires people to carry out research, and most people don't know how to do that. I didn't know how to do it at the master's level. So what we decided to do, we were going to have a research sequence. And guys, this is where you'll take our 6996, our 6997, and our 6998. This is a 2-hour course, a 2-hour course, and a 1-hour course. In the 6996, we give you an introduction to research, detecting bias, experimental design, so on and so forth. 6997 is where you begin to formulate your problem statement. This is where you get together. Well, these two actually work in concert. But between these two courses and formalizing it in 6997, we come up with your research research questions, your research goal. Guys, 6998 will be what you'll take the very last summer. That's where you come to campus and you present your results both in writing and orally. So part of the quantitative research component that I'm teaching now, the class 6610, where I have you do a final project, is kind of getting you ready for that part right there. The other part that we had to add to, I don't like that, that's just, that's annoying. The other part that we had to add to this is the quantitative research. You guys are going to know a lot about regression, but there are other methods out there that are sometimes used to explain relationships in education research. ANOVA, MANCOVA, MANOVA, so on and so forth. Again, in other words, the topics that you're going to learn in this class.